maybe beyond the NCRT limit. So we will skip on that there only. Okay. So you
Yeah.
try, you keep on trying. Okay.
Okay.
That's it. No, no, nothing to worry. Okay.
Okay.
Okay. So now I will ask you, what is difference between weight and mass?
Difference between weight and mass is uh, mass has
This font is okay.
which font, sir?
This screen is visible.
Yes, sir. Yeah.
Okay. Okay. So carry on. What is weight and mass? What is difference between weight and mass?
Uh,
What is mass?
Mass is when the force of two objects like attract each other. Or, I can't.
So what is your weight? How much
So,
kg you are?
sir, it's a like 45 kg.
45 kg. So that is weight or mass?
That is my weight.
That is your weight. What about mass? This is your
Mass.
45 kg. Okay, that's both term is not much different or not the similar. Neither both are equal or not both are different, right? What is
Yeah,
weight actually?
weight it changes and mass doesn't change.
That's good. How weight changes?
It depends on when you add more weight on an object, whereas the mass will never change of an object. It'll always
Okay, so
say
you are saying that in this container we are putting, oh, my container is very small. Suppose this is container. We are
okay.
putting this 5 kg plus again this 3 kg, then again 7 kg. So we can keep on adding. This is weight, right?
Yeah.
So this is weight. We can't do with mass.
Like mass of the earth never changes. It will always be the same.
Okay, mass of the earth never changes. If you build another Burj Khalifa, what will happen?
Nothing will happen. It will be the same weight. Mass.
No, you can't say. Because of these all buildings, skyscrapers, the time period of earth is being affected.
Okay.
Okay, so it's like that we charge our mobiles every day, right? So electron has mass.
Yeah.
So we are transferring actually electron to them to charge it, right?
Hmm. Yeah.
So when we charge our mobile, does it weight or mass increases?
Uh, yeah.
The same way when you will build another Burj Khalifa, the same way the mass of earth will change.
It will change.
Yes. If we are bringing some concrete from Mars to the earth, then surely it will increase. If we are bringing concrete from earth to earth, it won't change.
Hmm.
In sense, it won't change, right?
Yeah. It won't change.
Hmm. Because we are picking some concrete from earth surface and putting it on the earth surface. But
Yeah.
making those long skyscrapers, we are affecting the time period of earth as well.
Okay.
Okay. So it is still not clear what is weight or mass. So let me give you another question. that weight is the force being attracted by Earth. This is Earth center, and this is a body of mass m, and Earth attract it with a force m called m into g. This is called the weight, right?
Yeah.
So weight changes. Weight how changes? On the Earth, the value of g is 9.8 is a constant, right? Near the
Yeah.
Earth's surface is constant. So weight is F times G. F is equal to M times G,
Yeah.
right?
Yes.
Okay. But G is constant. G is constant, na? G is
Yeah.
constant. G is constant. So what will be weight will be equal to mass.
Mm.
We are multiplying with it a constant. So what it will make change? Nothing.
Nothing will change.
Yeah, nothing. So either you do with elephant or you do with ant. Okay, then nothing will change because this change and accelerate constant will remain, g will remain constant. So in one sense that weight and mass is a similar quantity, but in another sense mass is different from weight.
Yeah. Okay.
The sense is clear.
Yes, sir.
You are 45 kg, right? You are
Yes,
45
sir.
kg. If this is your mass, so on the earth you will be 45 kg. Even on the Mars, your mass will remain 45 kg. It won't change. But
Hmm.
your weight on the Earth is sometime 45 times g, and on the Mars will be again m times g. But the g will be different at both places, right?
Hmm. Yeah.
So your weight will change. So today we will do how it changes. Okay. So
Okay.
we have this data where we are telling you the mass of Earth and mass of Moon. So first, we have to calculate the weight. This is the same gravitational rule. Okay, F is equal to G time mass of Earth into mass of that object m divided by radius of Earth square. Right? This is force on a object at Earth. Right? So
Hmm.
we may replace at W E on an object, right?
Yeah.
So keep this as it, consider it's our weight, our mass. It's not weight, it's mass. Okay, where m is mass. And sorry, I could have mm, and when we are on the moon, that our weight will be like m moon. This will be nothing again, that constant g mass of moon into object mass divided by r e square. Sorry, r m square. Okay. So
Okay.
what you do a simple calculation. You just calculate, try to find weight of Earth divided by weight of Moon. You have all the datas. Okay, this gravitational constant will cancel out, right?
Yeah.
And you solve for both and divide. Okay, first solve for the first given quantity and then solve for the another given quantity and take the ratio and let me know what you get. Clear? Question is clear?
So, for the data, I have to do the G m m into m by radius square.
Yes. take the g as constant. Don't put any value because we finally we have to divide both. Okay. So
Okay.
don't put the value of g.
Okay.
For mass of moon, just put the mass of moon 7.6 into, sorry, 7.36 into 10 to the power 22 kg into that small mass divided by its radius 1.74 into 10 to the 6 meters square. Solve it and get the value. Similarly, do for weight of Earth. Okay, substitute the mass of Earth, leave the second mass as it, radius of Earth, substitute it, and then see what the ratio comes.
Okay.
This is your calculation for the day. Any progress?
Yes, sir.
Okay, then do.
Sir, I can't find the weight of the moon, but I got the weight of the earth.
Okay, no problem. No problem. See, can I proceed?
Yes, sir.
Okay. So this page is visible to you? No issue?
Yes, sir, it's visible.
Okay, so what I'm doing, just see. We have to find WE over WM. So can we divide it like this?
Mm, yeah.
So now what I will do, I will cancel this to this and this to this, right?
Yes, sir.
So I will be writing M E divided by R E square. Here will be M of M multiplied by R of M square. Clear?
Yeah.
Okay. So can you help me now?
It will be for five
Ma
point.
m Mass of Earth is 5.98. Can I write it 6? 5.98.
Yeah, rounding out will be 6. Yeah, 6.
So right. So just to make the calculation bit easier, 6 raised to the power
Then
24. What R of M? That R of M is 1.74.
4 into 10.
1.74, 1.74. Uh, I
2.
think let me do exactly. We will use calculator. Okay. I have mobile calculator. I will do the calculation. So don't worry. Otherwise,
Okay.
you must be thinking, see, sir is approximating it, and I was doing exact calculation. So
Yeah, so that's what I was thinking that 6 into 2 into 10. Like
into
10.
10 raised to the power 24.
Yeah.
What is R of ME? 1.74.
What?
1.74 into 10 raised to the power
Yeah.
6.
6.
What is R of E? R of E is equal to 6.7, like
3.
6.37.
6.37 into 10 to the power of 6.
6. And what is M of M?
7.36 into 10 to the power of 2.
7.10 to the power
10 to the power 22.
right? So
Yeah.
see, 10 to the power 6, 10 to the power 6. Clear?
Yeah.
And then this point to this decimal, and
Yeah.
for this decimal to this decimal, right?
Yeah.
Okay. And so is there any other color pen exist in nature? See, this is 22
Yeah.
and this is 24. So it will be only 2 to the power 2, right?
2. Yeah.
So this much is done.
Hmm.
It's not visible. You have to check this red only. So I'm writing on this astronauts. Then this is 5.98
Yeah.
into 1.74. Now I don't have a space. Give me a second. Deleting some bit space. Into 10 raised to the power 2.
Yeah.
What is left here? 6, 7 into 7, 6, right? Now, can I use a mobile calculator? If you want, you too can do. Okay, better you do.
I don't have a calculator now. And
You don't have calculator.
no, I have one, but it's on my shelf.
Okay, so I'm doing it.
Okay.
So it's 598, 598 into 174, 174, 598 into 174. So it is 10, 40, 52 into 10 to the power 2 divided by 637, 637 into 736, 736. So it is almost 4, 6, 8, 8, 3, 2, right? Now I'm dividing all together. 10, 0, 4, 0, 5, 2, 0, 0 divided by 4, 6, 8, 8 is almost 22.19. I think we did some mistakes somewhere in calculation. We did somewhere some calculation error. Mass of Earth 5.9824, and then R of M square. Oh my God! You know one thing. This was
Huh?
a square, na?
Yeah,
This was a square, and
yeah.
we did that. We didn't convert it to a square.
What? No, it's. Oh, yeah, we did.
So
So,
this was a mistake, blunder. This was a mistake, blunder, right? So how we will correct it?
uh,
We have to correct it. We have to correct it. So this is also not true. And oh, no. I won't do that. So this is 1.736. This is a squared, right?
yeah,
This is a squared.
yeah, and 6.37 into
6.
10 to the power 6 is square.
Yes. Our next one is 7.36.
No, no, 6.37.
This is a squared. So again, this, can I delete erase all?
Yes, sir, I can't understand when you're writing on the astronaut.
Yes. So can I remove the photo astronauts for the time being? No. Keep it. Keep it. We did a mistake.
If
That's why.
you can scroll it, so
So it was a mistake, but mass of Earth is 5 point. What is mass of Earth?
mass of Earth is 598
5.98
24
into radius of moon. Radius of moon is 1.74.
into 10 to the power 6.
1 into 10 to the power 6 and square. Again, mass of moon is 7.36. 36 in 10 raised to the power 22. Right?
Yeah,
And
6.37 into 10 to the power 6 square.
no. Give me a second. I will write in order. Okay. Mass of,
Radius of Earth and mass of Moon.
yes, consistent with mass of Earth is 5.9 and radius of moon is 1.7. Then here is radius of Earth is 6.7337 into 10 raised to the power 6
Square.
into s squared, right? Thank you. Squared
Into
into
7.36 into
mass of moon 7.36,
7.36 into 10 to the power of 22.
right?
Yeah.
Okay. Oh my God. So the next topic was pressure and thrust. So we really feeling pressure, right?
Yes.
So this is, I will keep that 5 point. Can I erase this point with this point?
Yes, sir.
Okay. And this 22 with this
24.
2.
2.
So it's bit relief now. 5.98. Sorry, point is gone. 598 into 10 square, right? This is
Yeah.
clear.
Yes,
And
sir.
here it will be 1.76 into 1.76. 76 into 10 raised to the power 12, right?
Yeah.
Okay, now this calculation took almost half an hour. We made one mistake and then 6.37.
Sir,
Okay. Huh.
how,
Yeah.
how is it 1.76?
1.74. This is 1.74.
So 1.76. Okay.
This is squared now, so we have written it twice.
Oh, okay, okay.
And this is 10 to the power 6. So we will write 10 to the 6 into 10 to the power 6 because base is equal, so exponent will be added. Okay.
Yeah, okay.
So again 6.37, 6.37 twice, and then there will be 10 to the power 12, right?
12, yeah.
And again 7.736, right? Now we will erase 10 to the power 12, 10 to the 12, this decimal with this decimal and this decimal, right? So now I am writing what we are left with, 598 into 174. This is 174 into 10 raised to the power 2 divided by 637 into 637 into 736, right? Now
Yeah.
it's time to calculate. 598 into 174 into 174. So it's huge quantity. I'm putting 20 as well. So this is somehow 181050480. What is next? 637 into 637 into 736. So this is 298645,984. Now it's time to divide the whole number with 1810504,800 divided by 1810504, divided by 298645,984. So it is coming around 6.60. 6.06. Okay, so this is around 6. Okay. Now take a deep breath. Time to take a deep breath. So what we calculated? Weight of earth,
The
weight of object on earth divided by weight of object on moon.
yeah.
So weight of object on earth divided by weight of object on moon is equal to is equal to 6. Means that weight of object on earth is 6 times weight of object on moon, or weight of object on moon is equal to 1 by 6 times weight of object at earth. No. Does this result Fascinated. Does this result make any sense?
I don't know, sir, anymore after all of this.
You said na that mass will remain fixed, but weight will change.
Because it will be 6 times more mass than on moon, because the moon doesn't have that much doesn't have gravity, so the weight will be less on the moon.
That's
So
that's happened. You are 45 kg on Earth. Then how
yeah,
much you will be on the moon? Around 7 kg.
yeah, 7 kg.
So holding you over there will be easier.
Mm, yeah, it's
So you
understandable.
will be little bit weightless. So
Mm,
you
yeah,
may, yeah, you may the wind will blow you over there if this much is something. If you will go on Mars, you may check how the Mars this thing will change on the Mars. Okay.
okay.
So does you feel anything after this huge calculation? Do we get some results?
Yeah, like a big achievement we found out. Big
Yeah.
achievement.
So now it will be in your mind. Okay. So if we will take the object to the moon,
It'll
the
be,
weight will be reduced by 1/6 time.
yeah, okay.
So it's okay. So I did a lot of calculation. Now it's time for you.
Mm,
This is the two questions. I think you will do in a minute.
okay. Of an object. Okay. Sir, what is the unit for this answer? Will it be Newton?
So now you tell me, will it be Newton or something else? What is the unit? My Newton is unit for what?
For force, I if I'm not like what's the I got the answer, but for the weight of the object on the earth, the
Yes.
unit is what?
How we define the weight?
M-E.
M-E?
Mass, no, mass of, no, that's
How?
mass of earth. The,
Yeah.
no,
No. Okay. Go ahead. Think.
kg? No,
How we define the weight? We define weight na?
W.
W.
W is equal to 98.
W equal to 98. From where you got 98? It's given the 10 only, na?
Yeah, but then we multiply the 10 because we're taking weight is equal to m into gravity, because it's m into acceleration, but we're taking as m into gravity. So W is equal to 10 kg into 9.8, because the gravity last time we got it as 9.8.
Okay, so this is similar to mass time acceleration, right?
Yeah,
So mass time acceleration is what?
mass into gravity.
Mass time acceleration is what?
Force.
Force. Okay, what is unit of force?
Newton.
So what is your answer? What the unit of your answer?
98 Newton.
98 Newton. Right?
Hmm.
So ask the question with yourself. Okay. You ask question to yourself.
Hmm.
You will get the answer. Because we did, I think, everything in details, right?
Yeah, I just wanted to make sure that's all.
Okay, good. So the next question
An object
is on the screen.
Yeah, an object weighs 10 Newton when measured the surface of the object when measured on the surface of the moon. So I got the answer.
You got the answer?
Yes, sir.
Then be happy.
Yes.
What's your answer?
1.67 Newton.
1.67 Newton. An object with 10 Newton on the Earth's surface. So it is just 10 over 6, right? 10 of 6.
So that's
Like that.
1.
1 point something, right?
Hmm.
So Mars are always in the news because you might have heard that a lot of country are doing their Mars mission.
Yeah.
Mars,
Yeah.
Mars mission. Okay. So again, I started writing on the curve line. So that's the bad habit across the board. That's bad habit. So my point is that why scientists are trying to find about the Mars. What could be the reason?
Because they are trying to make it like Earth also, like another planet for humans to live on.
So you know why they are trying to why they are thinking of so.
Because of the problems happening on the earth, like global warming and all that problems, are trying to shift to Mars now.
Okay, that's the reason. That's situation we are creating on the earth. Okay,
Yeah.
we are creating. We human are responsible. Okay,
Mm.
so why we are targeting the Mars? Why not to Jupiter, Neptune, Pluto, Saturn, some another?
Because
Why we
Mars,
are focusing on Mars?
because Mars is more like between not cold, neither hot, as other planets are far away from the sun, whether the other planets such as Mercury, Venus are close to the sun. So Mars is the same, almost same as the Earth. That's why
Mm.
they come on Mars.
So will you calculate the same ratio for uh, Earth by Mars? You will get data on MARS Mars. You will get data. You calculate the data on website or internet and try to do this calculation and tell me what will be the ratio of those things, right?
Okay. Yes.
So I never tried, but I only think that it will be it must be in the order. then only we can walk on the Mars. Otherwise, like this astronauts are feeling weightlessness. If we too will feel the same, then how could it work? It won't work, right?
Yeah. Yeah.
So either if this is much different, so we will be always flying on at the atmosphere or some way. So it won't be that much efficient to relocate over there. So
Okay.
if you get data, then do this assignment, and you must have to do because I did all the calculation. Okay.
Yeah. Okay.
So if you will do this, you repeat this calculation as well, Mars, Earth or Moon system. So you will get how to calculate the numbers in some efficient time,
Okay.
and then proceed for this system,
Okay, sir.
Earth and Mars. Okay. If you are able to calculate it, it will be good. You may present this as a poster in your schools, at your school. Okay.
Mm.
You calculate this and show this, and then calculate for Mars or Earth system, and then show what is the difference, why we are trying to relocate on the Mars. This you said, no, there is some similarity. I too, everyone knows that there is some similarity between Earth and Mars. That's why we are exploring that. Okay. So you do, if your results are approximately equal, then write a short notes, collect some pictures of Mars and Earth, and
Okay.
put in the classroom notice board. Okay.
Mm.
So we already felt a lot of pressure at thrust. So just give me what is pressure, and we will end for the class, right?
Yes, sir.
Because I think you are already under pressure of these calculations.
Now my brain started working too much, like what to do and all that. So it turned on.
Hmm. So what is pressure? How we will define pressure?
Pressure is the force. Um, it's pressure is like when you're applying a force on an object, on on a specific object on a surface area.
Yes, yes. So pressure is basically some another guy has started entering. It's around 9 now.
It's only 6 minutes left.
So people used to come before 5 minutes. Before
Really?
5 minutes, yeah, of course. Before 5 minutes, sometimes we do as well. We log in. Just to avoid the traffic, I try always to log in 1 or 2 minutes before.
Oh,
So pressure. This is force
applied
per
on.
unit per unit area. This
Hmm.
is the surface area, right? This is surface area. If we are applying force, okay, the pressure will be distributed all over the area, right?
Yeah.
If this is, suppose this is needle,
What's up?
needle.
Okay.
This is a tip, very thin tip,
Yeah.
right? So when we will put this on the wall, it will go inside the wall easy, little bit in easier
Yeah.
manner, right?
Yeah.
Why? Because this pressure will be, all the pressure will be concentrated at this point. That's why it's possible. Okay. This large sheet will float on the water, right? But we
Yeah.
will, when we will drop this needle, it will sink down. Why? Because the pressure will be distributed all over the surface area. But here
Hmm.
it won't be like that. So
Okay.
the needle will sink and the large plate won't sink. Okay. So this is the force per unit area, right?
Yeah.
So it's just bit definition, not in elaborated manner. We will do next day. Okay. We will start
Okay.
from here, right?
Yeah.
Everything is clear to about today's concept and calculation.
Yes, sir.
No doubt.
No, sir.
Okay. So then remember your assignment. Don't forget it.
Yeah, okay.
Okay. Then see you.
Thank you, sir. Take care.
You too.